Jim Davis here from Fluke Networks with questions for the TAC. We really appreciate it when you ask us questions, things that you don't understand. It helps guide us for new material that we could produce. Today's question is around the new inspection standard for fiber optic cables. The IEC 61300-3-35 has come out with an addition 3 to the standard. We're going to take a look at how we have applied this standard in the tester and how it's going to work for you. So to support the new edition 3 test limits in the version 6.13 firmware, which today is our current firmware, we've also added a couple of other features. One of them is a question that's come up where people said, hey, I'd really like to know right away if my tester is outside of its calibration period. So you'll see here when we boot the tester up that it's going to give us a warning 30 days before our calibration has expired. That will count down. Now, in the case of the module that I have, yes, it's out of its calibration period, but I've got a note right away. Hey, we're out of calibration. Now, the other feature that we're going to have, I'm going to set a reference and run a test here in a moment, but when we're going through our set reference wizard, and we really like the set reference wizard because maybe we don't test fiber every day and it helps us to get a good reference. We need a good starting point to do our testing. And you'll see that we've added a new button here, and the new button is Fiber Inspector, because maybe you've heard us say it before, you really want to inspect your fibers before you plug them in. So if we push that button, we'll jump right to the camera and we can do our inspection. Okay, let's look at this in more detail. I'm going to push set reference and it's going to tell me where I need to plug the cables in, but before I plug the cables in, I want to inspect them. And so we're going to set up a new test here, and the new test that we're going to set up is the fiber inspection test. And you'll see now when we go to more and end face limits that in addition to the old edition 2 test limits for fiber inspection, we've added the edition 3 limits. Now edition 3 is there to compensate for some deficiencies in edition 2. One of the challenges is a technical challenge. The technology isn't quite there to get consistent results about whether or not a fiber passes or fails. We really like red bad, green good, but it's a challenge, especially on multi-fiber connectors with all those small fibers. So the new limit takes that into account. It has 2 zones now instead of 4 zones, but it is going to ask us to look at the contact surface again. I think one of the main things that the standard does is it says, hey, let's give it a dry clean, and if the dry clean doesn't remove the loose particles, then let's give it a fluid clean. And that removal of the loose particles is very important because contaminated end faces are one of the biggest problems and the problems that we can avoid with fiber. I can't avoid the big yellow fiber finder. You've seen it, it's big, it's yellow, it's got a claw on this. It says caterpillar across the side. People use it to look for buried fiber optic cables. I can't stop that. I can try, but I can affect contaminated end faces if I have a camera. You've heard us tell stories before where we ask, do you have a camera? So edition 3 wants to make sure that we get the dirt off of the end face, and then we're going to see another very useful part of edition 3. We're going to try to clean the dirt off, but the fiber is going to continue to fail. It's continuing to fail. It's simple to replace a single fiber optic cable, but if I've got an array connector and I've got 12 or 24 fibers and I've got a 144 or a 288 trunk, I hate to send that back to the manufacturer being defective if the contaminant doesn't affect the light. So the new edition 3 limits are going to say if the optical performance is acceptable, then the optical performance will override too much dirt on the end face. All right, let's get a reference set. So here is my process for setting the reference. I'm going to select edition 3 multi-mode because I'm going to test multi-mode today just with a single fiber. We'll say use select and push test to start. So the first cables that I'm going to install are going to be my encircled flux, ready cables, and let's just take a quick look at this. I like to hold the connector with one hand and use a finger to just slide that on there so we don't mash it. And we'll We'll hit pause, we'll hit analyze. Ooh, look at that, a beautiful, perfectly clean fiber. And we will plug the red into the hot. Earlier today, trust that I did inspect the ports on the tester to make sure that they're clean. Oh, we're gonna take so much time for this. Now, once I've done that first connector, or I've got some experience working with connectors, I'll look at that and I'll say, yep, that's clean enough. Now, if you doubt, let's take a look. There, pass. It's clean enough. It's ready to go. Once you've looked at a few connectors, you'll have good confidence about whether they're clean or not. And we'll get this one. Beautiful. So we'll go from the output to the input so that we can set a one jumper reference. The one jumper reference allows the least uncertainty. Beautiful. One other comment, you'll see that I do have my cables coiled. That's bad. You should straighten them out. Do what I say, not what I do. The coil will increase the loss and give you pessimistic test results. All right, that's clean enough. So we'll plug that in. Now I haven't jumped into the wizard, and again, I'm showing you how I set a reference. And the way that I set a reference is to first inspect the cables before I start setting the reference to make sure that they're clean. Now, we're gonna go back to the home screen, and we're going to go to our smart remote test, and just gonna check how this test is set up. I know that I'm going to do a test that uses 3 connectors. I'm using the TIA 568 limit, so I have it set up for 3 connectors. One other option that I have in the test limit is I can choose from the TIA whether I'm going to use the standard or the reference limits. The TIA recommends, this is a length-based limit, as I add more connectors, as I add more fiber, I'll have more loss. Because I'm using high-quality reference-grade connectors, the standard knows that when 2 of these reference-grade connectors are plugged together, I should have better than 0.1 dB of loss. Now, if I take my high-performance connector and I plug it into a standard connector that might have up to 0.75 dB, the standard knows that 97% of the time, these will have less than 0.3 dB of loss. So the standard says for the first and the last connector, let's use a loss value of 0.5 dB. That would be our reference limit. Because it's a standard and not code, we also have the standard value, and the standard value lets you use 0.75 dB. Which one do you need to use? Depends on the performance of the connectors that you're testing. Are you using high quality connectors? The other question is, what application are you trying to support? I need to support 10 megabits Ethernet over 50 meters. Oh, you've got a whole bunch of loss budget, it won't matter. I'm running 400 gig and I have 4 connectors. You might want to use those tighter limits because you're going to have a tighter loss budget. We're going to stay with standard for today. We'll hit save. We'll hit start. There's the happy noise, we're connected. And I'm going to push test to start. And it's going to say, wait, before you start, you need to set a reference. Thank you, tester. We do certainly want to set a reference every day because we find that exactly how we plug in the cable to the output port here, the alignment changes a little bit and that causes different loss values. We want to get the most accurate test that we can. So let's go ahead and set our reference. The fancy people might skip our wizard, but I really suggest you walk through the wizard because it's going to remind you and walk you through each step. Now, because I've used the wizard once or twice before, we can see that I'm already set up along the image. What is the image showing us here? We're doing multi-mode, so our red output connector is in the multi-mode port, and the black input connector coming from the source on the far end is coming into the power meter. We'll hit set reference. Now, if the reference value is bad, if there's not enough light coming through, we'll get an error message, the tester will bark at us, but we're doing well. All right, let's push next. Now it's going to tell us to disconnect from the output from the power meter. Because the power meter doesn't make contact, there's a small air gap there that allows us to test both UPC and APC connectors This connector usually isn't dirty. I'm going to plug it into this coupler because I need to put it somewhere, and I don't want to set my unprotected fiber down on the table. Please, it will be damaged. So we're going to pull this one out, and we will plug it into a coupler because I need to put it somewhere. And then we'll go next, and it's going to say now we need to attach our known good cord. Is our known good cord clean? Interesting question. How will we find out? Push our new fiber inspection button. We'll take a look. Beautiful. Plug that in. Take a look at the far end. Beautiful. Plug it in. Now, another new button to help out. Follow the yellow brick road. The yellow button is the most likely button you're going to push, and it's going to tell me to connect these together. Now, before I connect them together, let's inspect and make sure that the new cord that I've attached has a clean port. And let's try not to confuse. Let's try not to plug the testers into themselves. Not that that ever would happen. So here's the connector that I pulled out of the port. Here's the new connector that I haven't inspected yet. Beautiful. Plug this one together. And just check our other one. Look at that. Glad I'm inspecting. I don't like that speck of dirt. That speck of dirt is off core, but I don't want to damage my test reference cords. I don't want to ask my boss to get me new test reference cords if they don't need to. Much better. Glad I gave it a click. All right, we're going to hook it together. And now a very important step. I want to both make sure that I started in the right place and prove to the person who's looking at my test results that I set a good reference first thing in the morning so that they can have confidence in the test results. So again, we'll follow the yellow brick road, we'll go back, and we're going to do our test reference cord verification, TRC verification. Always the most nervous part of the day because we want to get better than 0.15 dB. And we did. Beautiful. Now, this also brings up the other question, if you guys were watching carefully. Oh no, I used a green and a blue one. Can I do that? I thought green was just for APC. No, you can use both green and blue. How exciting. All right, our reference is set and we're ready to test our link. We'll go next. It'll show us putting our link in, and now we're ready to go. Okay, normally I just use this demonstration box. The demonstration box just happens to have two 50-meter pieces of fiber. But we wanted to talk about a specific aspect of the new 61300-3-35 standard, edition 3, and that is what happens if there is a fiber that I can't get clean. So I'm going to switch over to my fiber inspection test again. We'll use selected, we'll push test to start, and we're going to inspect this fiber. There you go. Now you're looking at that and you're going, wow, that looks pretty good. That should work nicely. I can see the core, but let's take a look and see what it says. Oh no, it fails. What does the standard say if it fails? If it fails, the standard says, do a dry clean. So we're going to do a dry clean, and then we're going to inspect it again. Might have gotten nervous. We'll click Analyze again. Oh no, it still fails. Now this contaminant out here, it has identified it, but it's marked it in green saying it's outside of the contact surface. We're less worried about that. Now because I want to keep this failing, I'm not going to do a fluid clean because I might be able to get this contaminant off. So I'm going to save this test result, and I'm going to save it as Edition 3 Demo 1A. And I'm going to plug it into my test reference cord. So we'll take our test reference cord. Boy, I hate to do this to my test reference cord, but such is life. And we're going to inspect the other end of this cable. Now I'm inspecting this because I can't tell you to inspect everything and not do it myself. There we go. Plug this into the demo box. And give ourselves a little bit of slack here. As I mentioned, you want to take the tie wraps off of these cables and straighten them out as you're setting your reference. Okay, so there is one end. Here is our failing connector. We're going to inspect the other end here. Make sure this is still in good condition. Beautiful. Now, of course, we need to test two fibers. I wonder if I can get two fibers to fail. Now, I can see that speck of dirt. I talked about it last time. I don't like that speck of dirt. I'm gonna get it out of there. Try to get it out of there. Again, if it's embedded in the end face, that one did come off. Now it's too clean and it's passing. All right, so we're gonna have one link that's gonna pass and one that's gonna fail. That's okay, I only need one failing link. So there goes that cable, and here goes this cable. I've just inspected this. Plug it in. Going to inspect this one. A lot of inspection going on here. Again, I don't like these specs off core. They're fine, they're off core, but I'd rather use up the thread in my cleaning tool than damage the SFP, the transceiver that I'm putting on the end of my cable. Plug that in, and here we go. This is going to be our good link, so this will be our B link. Let's save our, oh, maybe we can't get a failure here. No, we're not getting a failure. All right, I am going to save this as my B fiber, 01B, save. All right, so 01A has a failing inspected fiber, and 01B has, well, everything's passing. All right, there's the happy noise. We're connected. I'm gonna go to home. I'm going to change back to my loss length test. We'll hit use selected, and we'll push test to start. Now remember, we have a failing connector. Here is our failing connector. We failed the inspection. Will it pass or fail the loss test? Drum roll, please. The drama is too much. I can hardly wait 3 seconds to get the test result. Oh, look at that. It passed. And the total loss is 0.41 dB. This is where edition 3 comes through real nicely. I'm going to hit save, and I'm going to give it the same cable ID, edition 3 demo 01A, and I'm going to tap save there. Now, when I do that, because I've saved the same cable ID in the tester is going to merge the two test results for us. So now when we go to look at our test results, we don't have that failing inspection result. And when we look at edition 3 demo 01A, we can see that there are two test results. The loss length test that we saw passed by a mile, 0.41 dB of loss. It's fine. And notice how our previously failing fiber inspection test now has a yellow check mark. And we're going to say, yes, it has, look at that right there. We have a contaminant that's too large, but it's not affecting the optical performance. That's where edition 3 is so helpful. I want to avoid false failures. I have a single fiber here, that's nothing. But if I had an array connector, if I had one of 12 or 24 MPO fibers that failed, and it's on a 144 or a 288, I hate to send the whole 288 back to the manufacturer for the speck of dirt that's off core. All right, let's summarize what we've seen. The new edition 3 limits are going to help us to find significant contaminants in our fiber. We've updated the tester to give you a calibration warning, and this is small, but we've given you a new fiber inspection button at a useful spot while you're in the middle of setting your reference. This is Jim Davis coming to you from Questions for the TAC.